Hello, today we are going to look at a brief overview of the construction of a pitched roof and ceiling frame. So here we just have a very simple small layout of a house. I've just drawn this up in a free SketchUp program. So very simple, straightforward few wall frames in there. Just to avoid things getting a little bit confusing when talking about the roof, I've just taken a copy of those top plates which I've placed over here, and this is what we'll be working on today. So we're not going to look at any detailed construction techniques. It's just basic overview of the process of going through and building this roof frame. So the first thing you'll notice on these top plates is I've got a few pencil lines marked across here, and they are the positions of the rafters all marked out there. I'm not going to go through how to work out those positions. I've got other videos for that. But the one thing we do want to look at is that these marks are the edge of my rafters, and you'll notice if I turn the rafters are on one side of the line, and my ceiling joists are on the other side of the line. And there's a very important reason for that. The first thing we need to mark out is our rafter positions. But the first pieces of timber that we're going to install is going to be our ceiling frame. And here's the first members that I'm putting in. These are our ceiling joists. They just go from top plate to top plate. They take our ceiling sheets in from underneath. And we've got a few trimmers where the hip ends are and we can't get a ceiling joist right along the wall. We have to turn trimmers around there, lining up with those marks that we had for our rafter positions. So there's a reason we want to start with our ceiling joists, and one is to tie these top plates together so that the weight of our rafters don't push our wall frames out. The other reason is once my ceiling frame is in, I can lay some planks or maybe some plywood across them, and it gives me a relatively level platform that I can walk around on while I'm building the roof frame. Just makes it a lot easier to get those rafters up afterwards. So let's look at these ceiling joists. Now you can see that in a normal house, these ceiling joists may need to span quite a long distance. So I've got a couple of choices. I can either use quite large pieces of timber that can go across in one hit, or I can actually save a bit of money and use smaller pieces but support them through the middle. At the moment these are a single span ceiling joist. If I support them through the middle, it makes them continuous span, and it also halves the effective span that they have to carry. And we do that with hanging beams. And let me just turn them on if I find them in my list. There they are. So there's some hanging beams. So you can see over here, we've got a span there that's not very big, so that ceiling joist can span that, no worries. This span here is a little bit bigger. So I've got a hanging beam in there, obviously called that because the ceiling joists hang from them underneath. We'll nail some little cleats on there just to connect them so they can't separate. And the hanging beam is blocked up on the end by some blocking, or if you can't get blocking in, you might line it right up over the top of a ceiling joist trimmer here. And of course that angle is cut off just to suit the angle of those roof rafters, which I'll deal with in a second. So those are the hanging beams. Now this hanging beam here you can see is in the same situation as the ceiling joist. It's actually quite long, which means a huge piece of timber to span that distance. Or I can support my hanging beam halfway through the middle. And I do that with a counter beam. And that's the counter beam there. Just gives me a chance to halve the span of these hanging beams and reduce the size of the piece of timber that's got to be hauled up into the roof to do that. So there's our basic ceiling frame. Ceiling joists, hanging beams to hold up the middle of our ceiling joists, and counter beams to hold up the middle of our hanging beams. You'll notice over here these hanging beams don't line up with each other, and that's okay, provided these ceiling joists are not spanning more than they're allowed to, which you determine from the span tables. They don't really have to be dead in line with each other. And you'll find this is only positioned here because there happens to be a convenient wall sitting in a spot where we can run this off. And when you're dealing with a hand-pitched ceiling frame or a hand-pitched roof, that's really what it's about, is finding whatever you can find to prop things off and to block things up off. Right, so that's our ceiling frame. It's all nice and firm and supported. I can get up there with a few planks or sheets of plywood and I can start installing my roof members. So the first roof members I'm going to worry about are my common rafters and my ridge boards. So these get the basic skeleton of the roof up. These common rafters are the easiest rafters to cut up. There's usually multiple ones all cut the same through there and multiple all cut the same through there. Once we put those up, that gives us the basic kind of shape that we can fill everything else in. So the next thing, once we've got common rafters and ridges, we can get our angled corner pieces in, which are our hips and our valleys. So there's our hip rafter on this end, on that end. Here's our hip end on that side, and there's our valley going up through there. You'll notice this end is a gable end on the roof, so there's no hip rafters on that section. So anyway, we've got some shorter creeper rafters to put through here. And try that again without coughing. So we've got some shorter creeper rafters to fill in these corner pieces. So they're the next ones to go in. And that fills in our hip ends. You'll notice all those creepers line up with our ceiling joist trimmers. And we've also got the creepers coming down into this valley rafter here. These are our valley creepers. And you can see that is basically the main roof done. We've got a bit of missing roof over here on that gable end. Let's have a look at that end. Now there's a reason this is not built yet. That's because these rafters right out on the end, these are our barge rafters because that's where the barge board gets nailed to. Some people will call them verge rafters, it's the same thing. But whereas these rafters, they have both a ridge board and a top plate to sit on, this doesn't. There's nothing holding up this end. So we need to put in some framework to be able to hold up these barge rafters. So let's just get rid of that for a moment. The easiest way to do it, if I have a look at where this rafter hits, if I just grab the bottom corner of here and just run a line out along the ridge to give me a height, and where the rafter hits on the top plate, I can just measure that distance along there and run that line over here, and it gives me a finish point down there, and I can build a little gable wall like that. So you can see the top of the wall lines up with the bottom of that previous rafter, and the top of this point lines up with the bottom of that point of that rafter. And it's just really just measuring how far across the top plate it hits and copying that measurement there. So once this little end wall is in, I can run some pieces across to overhang that, and those pieces are called outriggers. So there's our outriggers going from our previous rafter, carrying over the top of that wall and coming out over the end, ready for us to nail our barge rafters to it. And that forms up that little overhang there. If I can get a view under there. So there's our overhang for our gable end built. Now you'll notice something, and any of you who have ever built a truss roof, you'll notice something looking a little bit different here. And that is that this rafter here is quite a distance back from that wall. Now, most truss roofs that I've built, whatever that overhang is, this next truss back here is the same distance back. But on this hand-pitched roof, the first rafter back is much further. And that's because trussed roofs are designed and engineered by the truss manufacturer. A hand-pitched roof like this is designed and engineered by the AS 1684. It comes out of an Australian standard. And the AS 1684 actually specifies that these outriggers have to comply with a certain rule, and that is that whatever the overhang is, the back span must be at least double. And that's why this rafter is so far back. Okay, so just in case you looked at that and thought, gee, that doesn't look a bit right, it is a different looking construction than a trussed roof. Okay, and the only effect is you've just got to make sure that when you put your roof battens on, your roof battens have an allowable span, and if that span there is too great, then maybe it's either a case of moving these blocking pieces back a bit or putting a second row of blocking through. But that is the basic shape of our roof. Alright, now we're going to worry about, we're going to have a look at these rafters. These rafters are also in the same situation that these ceiling joists were in. I can either use big size rafters to span the whole distance in one hit, or I can support them in the middle and use smaller size rafters and save a little bit of money in volume of timber. And what supports these is called an underpurlin. So before I put that in, I'm just going to turn off the ceiling frame just so it doesn't get quite so confusing looking at all these different lines. And in fact, I might even just turn those outriggers off too, just to make it a little bit clearer. So here's a view of the top of our roof. I'm going to throw in our underpurlins as soon as I find them. There they are. So a piece of timber that just runs all the way around. You'll notice it's not exactly halfway, it's slightly above halfway there, slightly below halfway there. That's just because I've got two different size roofs. And that's okay, so long as it's in the middle third, then that's okay. So it's in the middle third of both roofs. And that underpurlin just sits up underneath and supports the middles of those rafters. So of course the next question is, what is holding up the underpurlins? Well, I'm going to have a look around from this side, and I'm going to show you the struts. So there's a couple of fan struts in here, there and there. They just basically strut off a wall and hold up the underpurlin. But you'll notice this underpurlin, it spans a long way from where that's supported by that strut. It's trying to cantilever a long distance, so I need to strut something up here, but there's no wall to go off. And same situation over here, I've got a wall there to strut off, but nothing through here. So I need these struts to sit on something. And so I can use a strutting beam. And there's a strutting beam just blocked up off the top plates. Now I'm going to turn the ceiling joist back on so that I can show you something very important down here. I zoom in on that strutting beam and I just take a look under there. You'll see the strutting beam is not sitting on the ceiling joists. And that's because ceiling joists are not designed to take roof load. They're only designed to take ceiling load. So you cannot have your strutting beam sitting on top of your ceiling joist. Okay, and so if I turn the hanging beams back on, you can see the strutting beam. If I just get a bit of a view through there, you can see the strutting beam has been blocked up a little bit higher there. And over this end, I've just thrown in an extra trimmer, if you want to call it that, although it's sitting up above the ceiling, so it's not taking the ceiling, but it's a piece just so I can get that strutting beam attached and sitting on the wall frame. So ideally, if these cuts on strutting beams or hanging beams, if these cuts are too shallow and your beam is not sitting directly over the top plate, you might have to maybe put a strap or something on the back of those trimmers just to lock it together and turn that end into kind of a little engineered beam, if you want to call it that. just so that it's got decent support at the ends there and there. So we've actually got two different types of strutting beams here. We've got one that goes across over the top of our ceiling joist. We've got one over here that is parallel and sitting in between our ceiling joists. But there is still a requirement, if I get a view through there, there is still a requirement for that to be blocked up above the ceiling lining. And all of these blocking sizes, the distance that these have to be blocked up, they all come out of the 1684. So it's very important that that document, that AS 1684, becomes your best friend on the building site. So here we have an example of a vertical strut. We've got some angled cuts around the underpurlin and just a flat cut at the bottom. And we've got over this side some perpendicular struts where we've got some square checkouts around the underpurlin and our angled cuts are around our strutting beam. Alright, while we are on the subject of holding up our underpurlins, I want to have a look at this corner over here. You can see there are absolutely no wall frames that we can strut off, and we actually can't get any strutting beams either because we've got a hanging beam in the way of anything running that way, and we've got a counter beam in the way of anything running that way. So we've got a couple of options. One thing we could do is put a strut from the underpurlin down to the counter beam, but doing that comes at a price. Right now, this beam is a counter beam only, designed to take ceiling loads only. If we strut off it, it becomes a combined counter strutting beam, which means we have to use a different span table to size it. It has to get a little bit bigger so that it can take both roof and ceiling load. And it's very important to understand that if you size a piece of timber and you install it, you know what you have sized it as. And the same thing we can do around this way. We could run a strut down to that hanging beam and turn this into a combined hanging strutting beam. And if we were to do that, this hanging beam would get a little bit bigger. It would be a combined strutting beam, and you would find that that hanging beam would be a little bit bigger than this one because this one is only taking ceiling load. But for today, I've decided I'm not going to turn those into combined strutting beams. I'm going to use a different method to hold up this underpurlin. And before I show you what it is, I'm just going to turn off some rafters just so it's easier to see what I'm talking about. So I'll get rid of them. So I've got, I better turn that underpurlin back on. So there's my underpurlin. You'll notice the connection here is a little bit different. Over this side, the underpurlin has been cut around and underneath, and the underpurlin is holding up the middle of that hip rafter. But over here, I've attached a block to the underside of the hip rafter so that I can just have a straight cut, and I might have maybe a piece of metal strapping or something connecting that block on nice and securely, maybe some framing anchors holding the underpurlin on. Instead of using the underpurlin to hold up the hip rafter, I'm going to do the opposite and use the hip rafter to hold up the underpurlin, and I do that with a tie bolt. And there's a tie bolt. It's just a big metal rod which bolts at either end in a position that doesn't get in the way of the rafters. It's got a little support, and if you'll notice, it kind of looks a little bit like an upside down truss, and it works in kind of the same way, using that triangular shape to support the middle of that hip rafter. That hip rafter has now been strengthened, and it can carry the weight of the end of that underpurlin, which now goes across here. The underpurlin is now supported at both ends and is supporting our rafters. So that's our options. We can use a tie bolt to hold up the hip rafter, and the hip rafter holds up the underpurlin, or we can use a strut to hold up the underpurlin, and the underpurlin holds up the hip rafter. So those are our options, and of course This end would probably be our preferred option, but if we can't get any strutting beams through or any wall frames in the right spot, we have to go to our tie bolt. Alright, so let's get rid of all of those and we'll do a very quick recap over what we have just covered. We start off with our wall frame, our rafter locations marked. We mark out our roof frame first, but we install our ceiling frame first. So there's our ceiling joists, our trimmers in there. We use hanging beams to hold up the middle of our long ceiling joists, and we use a counter beam to hold up our long hanging beams. Once the ceiling frame is in, we can install our ridges and our common rafters to get our basic skeleton up. We then fill in our hip rafters to get the main shape, fill in our creeper rafters to finish off all the hips and valleys, throw in some kind of a support like a little gable end wall there so they can run our outriggers over, and put our barge rafters right on the end. Our rafters are held up by under purlins. Our under purlins hold up the middle of our rafters. Then we'll put some strutting beams on and some struts, and we'll strut off those beams and we'll strut off our walls to help hold them up. And any position where we can't get these struts up under our under purlins, we can install tie bolts on our unsupported hips. And there's only one thing left to do. One more piece of timber to go in, and that is these ones that go across from rafter to rafter right on top of our underpurlins, and this is a collar tie. There are rules in the 1684 about how often you have to put, or how many collar ties you have to put in, and how they are connected to the rafters. And the reason I make a point of mentioning these collar ties is because there is a definition in the 1684 regarding hand-pitched roofs. They are either coupled or uncoupled. This one here is a coupled roof. Part of the definition of a coupled roof includes collar ties. If it doesn't have a collar tie, then it doesn't comply with that definition. So I encourage you to look in the 1684 and look at that clause that covers what a coupled roof and what an uncoupled roof means. But this one is a coupled roof, and I will leave you to your own research to have a look at the differences between those definitions. So we have now constructed, in theory at least, a hand-pitched roof and ceiling frame. Now you might be thinking the same thing that I thought when I finished drawing this. Wow, what a lot of timber that goes into a roof. And that is exactly why people invented trusses. Trusses go in like a big box of Legos almost. They simplify the whole process a lot, but I do have to admit I really enjoy building these roofs. I've worked on a couple during my building career. I've built quite a few during my teaching career, and I really do enjoy working with these angles and figuring out the lengths and building something that looks really nice. And it's probably just me. I like the work that gives me a bit of a challenge. The stuff that not everybody can do, and I'll tell you right now, not every carpenter in the world could build a roof like this. In fact, probably not many of them could. So this is the kind of work I really enjoy. Unfortunately, it's not quite so common nowadays. Anyway, thank you and good luck.